Hi, I'm Dr. Nancy Van Wagoner. I'm a professor. I'm actually coming to you today from my home office, and I'd like to welcome you to Geology 1110, an introduction to physical geology. I'm going to be telling you about the course and what we'll be studying during this course, but I'd like to start by introducing myself. I just love teaching geology, and I'm really delighted that you're joining me on this course. I've been doing this for about 40 years, and I've taught just about every course that is part of a geology program. Like many of you, I enjoyed collecting rocks and fossils as a child, but I was also intrigued by big questions like what makes mountains and how did humans come to be on this planet? This inquiry stuck with me on again and off again through my undergraduate days, and by the time I graduated university, I was hooked. So then I was off to Dalhousie to do my PhD, and here I am. This is actually a photograph from Greenland, but we were working on a project in Baffin Bay, just a port stop there. And then to University of Manitoba for a postdoc, and here we are. This is the area of the Canadian Shield, and we're working on the volcanics up there. And since then, I've taught and I've done research in many places in the world. This is one of our research projects in Argentina. My specialty, though, is the study of volcanoes. I'm interested in this because this is where it all begins. Energy and materials from deep within the earth see the light of day for the first time. And volcanoes are like monitors recording how Earth has evolved, from the evolution of the very first thin crust to the system of plate tectonics we have today. My research has taken me to volcanoes ranging in age from the very young volcanoes actively erupting at mid-ocean ridges to ancient volcanoes that are about 2 billion years old and revealed in the glaciated landscapes of what is today the Canadian Shield. Closer to home, we're studying the 50 million year Eocene volcanics right here around TRU. And if you want to see more, I posted another video for you. Perhaps in the future, we can all go on a field trip together. But the reason I'm passionate about teaching geology is because it's just so important to all of us in our daily lives. For example, and here's something that you might not have thought of, geology is the practice of critical thinking and decision-making when there are unknown variables or the variables are poorly constrained. And isn't that the way life is? For example, if you invest in the stock market, you're using your best judgment based on certain variables that the price of the stock will continue to rise, knowing that not all of the variables can be predicted, and it just might not. And what about climate change? We know that increases in greenhouse gases are changing the climate, and we can model forecasts of the impact, but not precisely because of the uncertainty and complexity of the variables, and we'll learn more about this later on. Just based on these two examples, I think you can see that it's important to be able to make decisions even when problems are poorly constrained. And don't think this is just the job of the scientists. In the case of environmental issues, for example, and even health issues as we've seen in the current pandemic, scientists can inform city authorities and politicians, but how we respond, whether we build on a floodplain, use tax dollars to reinforce structures in earthquake-prone areas, or allow a development of a new mine, scientists inform, but the decisions are up to us, the citizens of this planet. And finally, our very existence depends upon Earth and how we interact with the planet, from the water we drink to our requirements for energy and mineral resources, even energy technologies, solar and wind, all require Earth materials. I've always believed since I was an undergrad, in the position that you're in now, that people are more likely to take care of the planet if they understand how it works. And finally, a thought that I often ponder is that we are made of the materials of this planet. You've probably heard the notion that we're star stuff, and that's true. And we'll talk about the solar system and how it formed from the materials manufactured in a supernova. But then, once the planet accreted, those materials that came to form the planet would eventually form our continents and our oceans, and finally us. And that's what inspires me to be here, teaching introductory geology. And that's why I'm just delighted that you've decided to join this course. Thank you.